I would like to create a whitelist for the Perl-Maven website. So if I log in as an administrator, it will only allow me to access from given IP addresses. That's an extra limitation of the security, but I would like to do this in the application level. The way we can do this is a background check now. So just checking whether the IP address is from the given list of IP addresses. Now the simple case is if I have a list of IP addresses that I am allowed and I put it in an array of whitelist, and then when a certain IP address arrives, then I can use the grep function here to check whether the given IP address is one of the values from the whitelist that I already have somewhere in the database. And then it prints out allow access or deny access. Obviously, the application will do the more complex thing of actually allowing access. Now, if I run the script, it will just say deny access in this case, because the provided IP address, which was incorrect, so it's 1235, but it's not in the list. And if I go back and edit this entry and put 4 in there and run the script again, then it will allow access. So a separate string is managing this whitelist. Now, of course, once the list is going to be long, looking up it using this grep is going to be time consuming, because the grep goes over all the list. And even if the first one matched, it will still go over the whole list. So when the list is growing, it's getting more and more time consuming. A better approach for that would be to use the list more utils module, and specifically to use the any function in it, and then instead of grep we'll use any. This will have the same behavior, so now if I run, this will allow the access, and if I give it 5, it will deny the access. So the function note is the same, but instead of going over the whole list, it will stop the first time it has a match. So it's an improvement. Still, if the list is long and we need to make a lot of lookups, it still can be time consuming. So there's an even better approach, and you might know this, is that instead of having an array of these IP addresses, we create a hash, and in the hash we'll have the key is going to be the IP address, and the value is some value, doesn't really matter. So we can use the map function, and I forgot to type the map function to create a pair where the key is one of the values from this list, and the value is just some value. In this case, I put in 1. And then instead of this whole calling of any, I'm just looking if the whitelist IP address, whether that's true. Some people would put here undef instead of 1, and then the question would be definedness, but this is also good. So if I run this, we'll get the deny, because I was checking the number 5 here, and if I put number 4, it will give me the allow access. So far so good, and this is immediate, so this is a very fast lookup, a little bit more memory needed for the hash than for the array, but it's much faster. Now, of course, that's good if the number of IP addresses is reasonable and if they are relatively random. But what if for some reason, you would do similar application and you would want to define the whitelist for a whole network? So, for example, all the IP addresses here, all the IP addresses that start with 1, 2, 3, and doesn't matter what here. There are 255 of them, which will already create a nice list of these IP addresses. But if you want to actually enable all the IP addresses that start with 1, 2, that will be quite a few IP addresses already, and that will just be a total waste of memory keeping them in a list or in an array. So instead of that, we are going to use a module called net subnet. Use net subnet. It provides a couple of functions, and we're going to use the subnet matcher function. In this subnet matcher function, it can create the whitelist. It can create any list using this function. So what we do is call the subnet matcher, and give it the networks. So normally, or if it's, and we can do this like this, okay. So if we have this fixed IP addresses, then we give the IP address and we need to give the mask of that IP address. Basically, we need to give an IP address and the mask. The mask can be given in either this way, or it can be given, here's another IP address. So now instead of typing in the whole mask of the four parts of 255, instead of get, I'm going to give the number of significant bits. Now, because there are 32 bits and I want to match the exact IP address, I'm telling it that all the 32 bits are significant. So this way, these are two ways. One of the ways this, and one of the ways this. This is what's called the CIDR notation, and this is the subnet mask notation. And this is the way we define the subnets. Now, the subnet matcher actually returns a function, returns an anonymous function we have just assigned to this scalar called whitelist. And then the way we are checking this is we call the whitelist scalar and then provide it with an IP address. Just we have to put the variable there. So this is how it works, and then I can run the script again, and it will allow access because we're checking the 4, and if we give the 5, it denies the access because we are looking for the exact same IP address. But what if we really want to allow all the IP addresses that start with 1, 2, 3, doesn't really matter what, and then we want to give the number 0 here. This way, doesn't matter which IP address we give, the 5 at the end, or the 4 at the end, it provides the same access because they are all in the range. Now, if we happen to give a different IP address here, which is where the third element already differs, then it will deny the access. So in this way, we can create defined networks easily. It doesn't have a lot of memory consumption, and it will be able to decide whether the given IP address we provided here in this function, whether it's in matching this IP and network mask or not. One thing that you have to note about this module, that if we give here an incorrect IP address, it just returns false. It doesn't actually do anything. It doesn't care. No, what happens if this is actually something? So this should be this is true, right? So what if we are going here give here something, and he gives false? So this is as the address. So we gave some garbage IP address, and we get back a deny. But what happens if we give a different mask here, for example, 256? It doesn't check if the input is correct. So what the author of the module said is garbage in, garbage out. It doesn't check whether the input, neither here in the masks, in the definition of the subnet matcher, nor whenever we are checking the IP address, it doesn't check whether the IP address is correct or the numbers are correct. So it's our responsibility to check that. And then the return value is going to be, I think, random. Now, we saw this isn't for IPv4, but actually the module also works for IPv6, but I didn't need it for this case.